All right, in these problems, what we're going to do is we're going to find a missing leg length. All right. So again, in order to do that, we're going to use the Pythagorean theorem because we're dealing with right triangles. So again, Pythagorean theorem is a squared plus b squared equals c squared. Remember, identifying that a and b are leg lengths and c is the hypotenuse. Okay. So in this one, we're going to identify first the leg lengths and then the hypotenuse. So the leg lengths are the two lengths that make up the right triangle. So I see that 5 makes up one leg length. N makes up the other leg length, so B is going to be N. A is going to be 5, and B is going to be N, which means that C, or our hypotenuse is going to be 13. All right, so we go ahead and substitute that into this equation, a squared plus b squared equals c squared. So I'm going to put 5 in for A, so I'm going to have 5 squared, plus b squared, which we had was N. So I'm going to have n squared, equals c squared, which is 13, and so that's going to be 13 squared. So I'm going to go ahead and simplify. I'm going to do 5 squared, which is 25. I cannot simplify n squared right now, so it's just going to be n squared. I can simplify 13 squared. 13 squared is 169, because 13 times 13 is 169. I cannot combine 25 and n squared because those are not like terms. So what I'm going to do is I'm going to move the 25 over here with the 169 by subtracting it, and so that it cancels out on the left side. So this cancels out over here. This leaves me with n squared. 169 minus 25 is 144. Now that n is by itself and I have everything simplified, I'm going to do the square root of n squared, because when I do the square root of n squared, that's how I get rid of this squared, and I end up with just n. Over here, I'm going to do the square root of 144. And the square root of 144, it's either positive or negative 12. The answer that makes sense in this one is it's going to be a positive 12, because this length has to be positive, because this one's 5, this one's 13, and you can't have negative lengths of something. All right, so it's going to be n equals positive or negative 12, or in this case, it's going to be positive 12. Let's go ahead and look at the other one. I have 8, 3, and a y. Right here is my right angle, so I'm going to identify the legs first. A is going to be y, because this is one side of the 90-degree angle. B is going to be the other side that forms the 90-degree angle, which is 3 inches, which means that C is 8 inches, or hypotenuse is 8 inches. So I'm going to again use the Pythagorean theorem, a squared. I'm going to slide this over a little bit. A squared, which is going to be y squared in this case, plus b squared, which is 3, so I'm going to do 3 squared, equals c squared, which is 8. I'm going to go ahead and simplify. I cannot simplify y squared right now. I can simplify 3 squared, because 3 times 3 is 9. 8 squared is 8 times 8, which is 64. My next step that I'm going to do is I'm going to simplify. I'm going to move the 9 over next to the 64 by doing the opposite. Since it's adding, I'm going to subtract 9. This will leave me with y squared on this side, because those cancel out. 64 minus 9 gives me 55. How do I get rid of the squared? I do the square root. I'm going to do the square root of 55 over here. As a result, square root of y squared is y. Now, when I do the square root of 55, I have some difficulty here, okay? Because square root of 55 is not a perfect square, and we've not seen that, all right? I can get an approximate answer. I know that it's somewhere close to probably somewhere around 7.7, 7.6, somewhere in that range, because it's between 7 and 8. I could write it as a decimal, or I can just, if I want to do it an exact answer, I'm just going to say that y equals the square root of 55, all right? I just need to understand that the square root of 55 is somewhere between 7 and 8, about 7.6, 7.7, somewhere in there, okay? So the leg length for this one is square root of 55.